So in today's video, we're going to look at linear sequences. So linear sequences are probably sequences that you've seen before. But anyway, this is just a reminder of how linear sequences work. So linear sequences are sequences where a constant real number is added to each term of the sequence in order to obtain the next term. So we've got a constant real number that we're adding or subtracting as well to each term in the sequence in order to obtain the next term in the sequence. So for example, these two sequences here would be examples of linear sequences. So to go from, if we look at example number one, to go from this term to the next term, we add 4. Same with this term, same with this term here. So every time we go to the next term in the sequence, we're adding 4. So that's what a linear sequence is. Likewise with this one down here. So from the first term to the second term, we take away 2. From the second to the third, we take away 2. From the third to the fourth, we take away 2. From the fourth to the fifth, we take away 2, and so on and so on and so on. So we're adding the same number each time to obtain the next number. That's a linear sequence. So they're just two examples of linear sequences. So let's consider the a general formula for linear sequences. So let's say we've got a linear sequence like this. So A and then A plus D. So this one, we're adding D every time. So we start with A as our first number, we add D, then we add another D. So again, adding that same number to obtain your next number in the sequence, then adding D again, then adding D again, and so on and so on. And again, A and D are just normal real numbers on the real number line. So the nth term of this sequence, what would the nth term of the sequence be? So the nth term is going to be this. So it's going to be this difference D, this difference value D, multiplied by N. And then in addition to the gap between the difference and the first term, so the gap between the difference and the first term, so that's going to essentially be, the difference between the gap and the first term. That will be, so A take away D. So the difference between the first term in your sequence and the difference, the common difference of the sequence, the D value, that's going to be your constant value at the end. So essentially, we've got this coefficient D of the n plus this difference between your first term and the difference of the sequence. And the iterative formula, so that's the nth term. The iterative formula is going to be this. So it's going to be an plus 1. So the next term in the sequence is equal to the previous number in the sequence plus D, where the first term in the sequence, A0, is just equal to this first term there. So that would be the iterative formula for the sequence. This would be the nth term of the sequence. So for example, if you wanted to work out the 100th term of the sequence, you would just plug in n equals 100 into the formula there, do D times 100, this difference times 100, and then plus the difference between your first term and your difference, and that's going to get you your nth term formula. So let's look at an example here. So let's look at the example, actually the same as this second example here. So how do we calculate the nth term of this sequence, and how would we obtain the iterative formula? So the nth term, so again, it's going to be the difference times by n. So with this linear sequence, we've got a difference or a gap of -2. So we're going down by -2 each time, -2 each time, -2 each time. So it's going to be a negative 2n. So our D value is basically going to be -2. So D equals -2. And our first term is the number 10, as we can see in the sequence, it's number 10. So that's going to give us -2n and then plus a constant number at the end. That constant number is going to be 12 because D take away A, using our formula back here, or A take away D, I should say. That's going to give us 12 because A take away D equals 10 minus -2, which is 12. So we get a plus 12 there. So our nth term for this sequence is going to be -2n plus 12. And we can verify this. If we plug in n equals 1 into this formula there, we get 10. If we plug in n equals 2, we get 8. N equals 3, we get 6, and so on and so on. So that's going to be our nth term of the sequence. And how about this iterative formula? So again, an plus 1, the next term in the sequence is going to be the previous term, so an, and then in addition to the difference here is -2, so actually an -2. So that's going to be our our iterative formula for this sequence. But with the first term, a0 equals 10. So that'll be the first term of the sequence. So that's how we would obtain a nth term formula and an iterative formula for a linear sequence like that. Let's just consider one extra question though before we finish the video. So let's consider 3n minus 1 as an nth term of the sequence. So this is an nth term of the sequence here. So consider 3n minus 1 as an nth term for a sequence. So the first question is, does the number 80 appear in the sequence? Okay, so let's answer this question. So what we're going to do is we're just going to substitute, we're just going to make the nth term of the sequence equal to 80, because if 80 were in the sequence, then there's going to exist a positive whole number and a natural number, which is going to give us 80 in the formula. So we're going to make 3n minus 1 equal to 80. We're then going to rearrange for n and we're going to see what we get. So we're going to get 3n equals 84 when we add 4 to both sides. And then when we divide by 3, so the number 84 divided by 3, if we just use like a little bus stop method here. So 3 goes into 8 2 times, remainder 2. 3 goes into 24 8 times. So n is going to be 28. So that tells us that the 28th number in the sequence is actually going to be 80. So 80 is the 28th term in the sequence, because the n value of 28 gives us a term of 80. So therefore 80 is in the sequence. Now, if n was to be a decimal number, so not a natural number, or a negative number, for example, then 80 wouldn't be in the sequence. But because n is a positive whole number, that tells us that it is in the sequence, because it's going to be the 28th term in the sequence. So therefore 80 is in the sequence. And then the next question, so what is the first number in the sequence to exceed 150? Okay, so again, if we just, for this one, again, we're going to use that formula 3n minus 4. And we're going to set this formula 3n minus 4 to be greater than 150. And we're just going to solve the inequality. So add 4 to both sides, we get 3n is greater than 154. Divide both sides by 3. Again, just going to use a bus stop method for this. So 154 divided by 3. How many 3's go into 1? That's just going to be 0. How many 3's into 15? That's going to be 5. How many 3's into 4? 1. Remainder 1. So essentially what we get is that n is greater than 51 and 1/3. So therefore, first term in the sequence to exceed 150 is going to be the 52nd term. So first term to exceed 150 is the 52nd term. And what number is this actually going to be? Well, we can just plug that into the formula, the 3n minus 4 formula. And if we do that, we're going to get, so 3 times 52, take away 4. So that's going to be 156, take away 4, which is 152. So 152 is going to be the first number of the sequence that exceeds 150. And the number 4, that would be 149. That would be the 51st term, but that's obviously smaller than 50, and we want it to exceed 150, sorry. So the first term to exceed 150 is the 52nd term in the sequence. So yeah, that concludes today's video. Just a summary of linear sequences, linear nth terms, linear iterative formulas, and doing calculations with linear sequences.